Alrighty, here we go. Another fun installment of Will This Year Ever End for you guys. Next fun is sequence and series, probably the most horrible thing that happens to American children in mathematics. And we are going to talk about explicit formulas, yay. So we need to decide if it's arithmetic, geometric, or neither. Arithmetic and geometric have formulas we follow. Neither, you have to use your brain, which is just unheard of these days. So, excuse me, going through arithmetic means that there's a difference, some are difference. Geometric means it's multiplication. So if you look at these first numbers, they A, should be familiar to you, and B, if you tried to find out addition, you'd go plus 3, plus not 3, so it's not arithmetic. Then you'd do multiplying, times 4, times not 4, so it's not geometric. So this one's going to be neither, which means you have to think, how do the numbers you see relate back to the term number that they are? So if you take a good look at those numbers, you can see that they are the bottom number squared. So like 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, and so on. So my explicit formula is simply that to get any term, you take the term number and you square it. So that one you have to do using your big brain. Then here, when I look at this next one, I can see that these are going up by a common difference of 2. I almost wrote plus something not 2. So here we go. Okay, so the formula that you should probably have on your sheet is that you take the first term, plus or minus, in this term it's adding, the common difference, and then you do n minus 1 as your explicit kind of formula. So for me, my first term is 3. My common difference I decided was 2. So I distribute that out. The 2 becomes 2n minus 2. So my explicit formula is 2n plus 1, because the 3 and the minus 2 combine. And you can test it out. Like if you're looking at this later, you can be like, this is my final exam and I want to do super duper awesome. So let me try one out. This is the third number. So if I put a 3 in here, 2 times 3 is 6 plus 1 gives me the 7 that appears. So that rule seems to be working. Alrighty. Here, that was arithmetic. No surprise, this one's geometric. When I go through this, it is times 2 times 2 times 2 and so on. And so they're doubling. The numbers are all doubling. Excuse me. And so my formula for arithmetic was this. My formula for geometric is to take the first term and then whatever that common ratio is to the n minus 1 power. So in my case, my first number is a 5. My common ratio is 2. And then you can't do anything. Like you can't distribute or do anything else. So this is actually your answer, and I'm too lazy to rewrite it. Okay, recursive. Recursive is when it relies on the previous term. And keep in mind that the term before this one is going to be the n minus 1th term. It's like the one before, and then the one after would look like this, and before that would actually be n minus 2 because it's 2 before this. They're all kind of referencing, are you before or after that number? Kind of like a number line. So if you think of this as 0, this is 1 to the left, 2 to the left, 1 to the right, and so on. So these are the same as up here. So I already know that this one's arithmetic and geometric. So I have to tell people what the first number is. In a recursive, you always have to tell the first term so they know where to start. And then you have to tell them what to do. So here, to get any term, you're going to take the previous term and add 2. So this first part says, hey, where should you start? And this says, what should you do to the previous number? You should start at 3 and just keep adding 2. So similarly here, you have to say what the first number is, which is 5. And then we already looked above and realized that you're going to have a common ratio of 2, so you're multiplying by 2. So the second part is to say, hey, what I want you to do after you start at 5 is take the previous term and multiply it by 2. And because I'm a math teacher, I can't resist putting it out front. So I'm going to start at 5 and then double each term. So those are just kind of always how these work. Like for common difference, you're always going to have a plus or minus at the end. And for for geometric, you're always going to be multiplying by a number. All right. So you again have to kind of categorize these so you know if there's a formula or not. This one is not arithmetic or geometric. We learned that up above. So I have to grind through it and go, okay, what if I plug in a 1? Because remember, you start by plugging that number in, and then you keep going until you get to that top number, which is telling you where to stop. And then you have to just go ahead and do it. There's not like a shortcut formula that you can use for that sum. So I'm going to just add these up. And I'm getting 55. All right, so anything that's linear, meaning like y equals mx plus b-ish, and this is just 2n plus 3, that is going to be arithmetic. And if it's arithmetic, we have a formula. Your formula is the sum of a certain number of numbers is that number over 2, first term plus last term. Alrighty, that should be on your sheet probably. So how many am I adding? Well, it's going from 1 to 25, so I'm adding up 25 numbers. And what would the first one be? I don't know. So to get the first one, I got to plug in a 1 to my formula. So that's going to be a 5. Then I need to do the last term. A sub n means the last one. So you're plugging in basically just the bottom and the top number. So to figure out this last number, I'm going to plug in a 25. And so that's going to be 75 plus 3. And then I'm going to get my trusty, rusty calculator out. And I'm going to type all that beeswax in there. I got like a weird number that I think is wrong. Let me try again. So 25 over 2. And then I'm going to multiply that by 5 plus 78. Okay, so I just got a weird number. And all that means is you would be doing this to all the numbers and then adding them up. Something's not right. Maybe it is. I don't feel like I want to have a decimal, but because I had to divide 25 in half, that's what happened. Okie dokie, Smokies. Let's take a look at this bad boy. This is in geometric form. It's got that a1r to the n minus 1 power. I can tell that I'm looking at something geometric when I have that n minus 1 power. This one's going from 1 to 17, so that's too many. I'm going to use my formula for geometric, which says to take the first term, and then 1 minus the ratio to the however many you have, which will be 17, over 1 minus r. So that formula should be on your formula sheet. So my first term would mean I'd be plugging in a 1. 1 minus 1 is a 0 power. 0 powers make, like, it would be 2 times 3 to the 0 power. So this becomes a 1. So my first term is going to be a 2. Common ratio is whatever's inside, so it's going to be a 3. So 1 minus 3 to the 17th power, because I'm going to 17, over 1 minus 3. You do have to be a little careful of this. I always do 1 minus 3 to the 17. I do that top part first on my calculator. And then I end up with like a really giant number. I have a 2 out front. I don't even know if I can fit this in. Oh, sure I can now. Over 2. These cancel. And so I actually, sorry, this would have been a negative down here. So the negatives cancel as well. So that's not always the case because the bottom number is not always 2, but it just happened in this case. And so then this is going to be my answer. Either way, I highly recommend doing this first on your calculator, then dividing by whatever this is, and then lastly multiplying by the number out in front. Now this one goes to infinity, and you guys don't have that kind of time. Like you either have to graduate or become a senior, so you can't just sit around and add to infinity. So good thing there is a formula for that as long as your ratio is less than 1. Otherwise you can't do it, but you can. So what is that formula? It is first term over 1 minus r. So I've got this on my sheet and I know how to use it and when. I've got this on my sheet. I've got this, but you got to know when to use them and how to use them. So make sure you set yourself up for success. All right, what's my first term? Well, if I put a 1 in here, I'd get a 0 power. That would make all of this business 1. So I'd end up with a first term of 1. And then the bottom's going to be 1 minus my ratio. Well, the ratio is whatever's in the getting raised to the power. So that's a half, which I'm going to put like that. 1 minus a half leaves me with a half. And when I do 5 divided by 1/2, not 5 divided by 5 divided in half. It's 5 divided by half. So I get 10, because there would be 10 halves in 5. And if you don't care, just use your calculator and ignore me. Okie doke, here we go. I said okie doke like 1,000 times, I'm sorry. Factorial means keep going down by 1. So this one means n plus 3, and then n plus 2, and then n plus 1 to n, and then it would go n minus 1, and so on down to 1. N plus 1 factorial would start here with the same stuff. So the catch in this whole business is that from here on down, everything would cancel out, and all I would be left with is these two. And I'm a big person math, so I have to FOIL it out. So my proper answer is n squared plus 5n plus 6. Boom. All right, we're switching gears now. We're going to go into limits. Thank goodness we're done with sequence and series. I have to hurry, or you're going to be coming in here soon. So what does this mean? We talked about notation so much because it's so confusing. This is talking about positive here, negative here. X, this is the x-axis. So as x goes to infinity, it's simply talking about the right end. What is the right end doing? Here, the limit as x goes to negative infinity, you're looking at over here, so it's simply asking you about the left end. We did end behavior before, we're just giving it fancy language. All right, this first one's asking me to look at number -2, but because of this, I'm looking at it from the left. So here's -2, and here's to the left of it, so I'm on here. What am I approaching? 1. This is asking me to approach -2 in general. Well, this is not actually going to have a limit, because if I had approached it from the right, I'd be down here. And since the left limit does not equal the right limit at that -2 value, this is one of those good old DNEs. There is no overall limit. Next, I'm looking at the overall limit for 1. Where's 1? Right here. What happens if you come from the left? You go towards 1. What if you come from the right? You go towards 1. So since the left equals the right and they're both approaching 1, the answer is 1. All right, but what's the actual function's value at 1? So that means go to 1 and find the actual spot where the graph exists. And that's right here at -2, because up here is an open circle. So that's not really a value. Okay. End behavior. We talked about the right end, left end, up, down, all that business. So let's find that in terms of limits. So what we learned back in the day is that we look at this power as its highest degree and it's odd, which tells us that it's going to be opposite ends. And then this number is negative, which tells me the right end is going down. So this is the right end because x is approaching infinity, and I don't say going down, I write -infinity. Since the ends are opposite, my left end's got to go up, so it will approach positive infinity. Alrighty, this is going to be where I factor the top, because that's difference of squares. Now, if you're still struggling with factoring, I don't know what else to tell you. And on the bottom, I got to factor that. And then I cancel. Any canceled factors, whatever would make that 0. And these would be 0 when x equals 4, because 4 minus 4 would be 0. That's going to be the x coordinate for the whole of my graph. How do I find the y coordinate? Well, I plug a 4 in to this simplified version. So if I had 4 plus 4 over 4 plus 1, my y value is at 8/5. There will be a hole in the graph there. Now the other uncanceled bottom factor generates a vertical asymptote, and it will be located at whatever makes it 0. It's a vertical line, so I write it as such. To get this thing to be 0, I would need x to equal -1. Now horizontal asymptotes, I'm going to go back and look at it in its original form, and I'm looking at the first two. Here's where I compare the top and the bottom, and in this case the top and bottom powers are the same. So I hopefully have this written in my notes, that will mean that I'm going to have a horizontal asymptote at y equals their coefficients. Since it's 1 over 1, that is at 1. Now, I'm not going to have a slant asymptote because you can never have both of these. I would have one if the top was greater than the bottom, but I don't because the top was equal to the bottom. So this is again asking what the right end is doing, and this is asking what the left end is doing. Keep in mind, if you have a horizontal asymptote, it will be going towards that value. So since I had a horizontal asymptote at 1, both ends will approach 1. And now we're on to the thing we just did, calculus, yay. Average rate of change is slope. So I go back to my roots here as I end my free high school math career, unless I'm a junior. I put in a 0 and I put in a 2 because these are x1, x2. No y's given, and I know that because of these brackets instead of parentheses. So like you have done since the beginning of your math time, you're going to find the y's by plugging them into this. So I'm going to have 2, 0 cubed minus 12, 0 squared minus 3. These are all zeros, so this is my answer. Here I have to plug in a 2. That looks like a lot of work to me. Oopsies, that's cubed. And then minus 3. I'm going to bust out the calculator. So 2 times 2 cubed. Why I'm so slow, I don't know. I'm having like a little brain fart right now. I'm getting -35. What a lovely number. And then I just use slope. y2 minus y1 over x2 minus x1. So I'm using these now like regular old points. This changes to adding, so I get -32 over 2, so -16 is my average rate of change, because that's what's telling me to use slope. Instantaneous rate of change is telling me to find the derivative's value at the number they gave me. Well, I can't do that unless I know the derivative. So let's revisit the problem. If this up here is the original function, its derivative will be 3 times 2, so 6, and then the power of x goes down by 1. 2 times -12 times x, and then the power goes down by 1, and then a constant disappears when you're doing the derivative. So here's what I have for a derivative. I am going to plug in a 3. So I'm going to have 90. That doesn't seem right. It's not. I got -18. That seems more right. Does it have any max or mins? This is a yes/no question. So what that means is there a place where the derivative equals 0? I don't know. Let's take the derivative and see if we can make it equal 0. 6x squared minus 24x equals 0. I have to factor, so I'm taking out a GCF because you got to check first. Pulling out a 6x leaves me with x minus 4. Will that ever equal 0? Yes. If so, at what x values will they be located at? Well, what would make this 0? 0. What would make this 0? 4. So those are the two x values where my max or mins would be located. It's not asking me to do a sign chart and figure it out. It's just saying, do they exist? Where are they? This is a separate and general question. When the derivative is positive, the function is doing what? Well, if the derivative is positive, it means it's sloping up, and so that means the graph is increasing. Whereas if it had been negative, it would be decreasing, and if it was 0, it would be a max or min. And then this isn't even making you do the difference quotient. This is asking you what formula you would use, and that's this bad boy. I tortured you with that a lot between IXLs and paper. So we're gonna call that a wrap. And that's the last thing you're gonna do in this class is take my final. And this little question right here is gonna be the last one I get to ask you. So thank you guys for making my year amazing. And I will miss those of you who are seniors, so come back and visit. Those of you who are juniors, I look forward to seeing you next year and celebrating your senior year with you. Bye, guys.